Hello everyone. And previous lecture, as we know, we are already studied about the basic terminology of the cement. Now we are proceeding for the types of Portland cement. So basically, here five types of Portland cements are performed. So type one is type one, two, three, four, five, and type one is also known as regular cement. जनरल यूज के लिए यूज होती है और ये OPC आती है, ऑर्डिनरी पोर्टलैंड सीमेंट होती है. टाइप टू विच इज मॉडरेट सल्फेट रेजिस्टेंस सीमेंट होती है, मॉडरेट हीट ऑफ हाइड्रेशन होता है, ट्राई कैल्शियम एल्यूमिनेट इज लेस देन 7%. टाइप थ्री विद इंक्रीज्ड अमाउंट ऑफ ट्राई कैल्शियम सिलिकेट, हाई अर्ली स्ट्रेंथ देती है ये. टाइप फोर इज लो हीट सीमेंट एंड टाइप फाइव इज हाई सल्फेट रेजिस्टेंस सीमेंट. ये टाइप वन टू थ्री फोर फाइव जो है आपके, ये अलग अलग इनकी क्वालिटीज दी गई हैं, कौन सी टाइप की सीमेंट में किस चीज की एक्सेस होती है या फिर किस चीज की कमी होती है. सल्फेट कैन रिएक्ट विद ट्राई कैल्शियम एल्यूमिनेट सल्फर to form an expensive product by reducing the tricalcium aluminate content. There will be less this chemical formed in the hardened paste. So tricalcium aluminate is also a major important role for the concrete. So the typical chemical composition of the is given in the table. So here is the components which are tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminiferate CS, H2 fineness, compressive strength, and heat of hydration. If we are talking about the type 1, so tricalcium type 1, 3, 4, 5, so tricalcium silicate, which is for type 1 is 50%, type 2 is 45%, type 3 is 60%, type 4 is 25%, and type 5 is 40%. And for dicalcium silicate, for type 1, this is 25%, type 2 30%, type 3 15%, type 4 50%, and type 5 is 40%. And for tricalcium aluminate, which is in 12% in type 1, 7% in type 2, 10% in type 3, 5% in type 4, and 4% in type 5. Tetracalcium aluminiferrate, which is in 8% in type for type 1, for type 2, which is 12%, for type 3, this is 8%, type 4, which is 12%, and for type 5, this is in the form of 10%. CSH2, which is in for type 1 to 3, which is same as 5%, and for type 4 and type 5, which is 4%. Fineness, which is meter square per kg, which is 350 for type 1 and type 2, which is same, 450 for type 3, 300 for type 4, and 350 for type 5. Now if we are talking about the compressive strength, which is 7 Newton per mm square, 6, 14, 3, and 6 for 1, 2, 3, 4, 5 respectively. And if you are talking about the heat of hydration, which is in the form of 7 days and joule per gram, 330 for type 1, 250 for type 2, 500 for type 3, 210 for type 4, and 250 for type 5. From the above table, we can evaluate the behavior of each type of cement and provide the standard in selecting different cement types. The following figures show the strength and temperature rise for the different types of cement. So basically, here is the graph which represents the temperature rise in mass concrete and time, which is in days, for these four types of cement. These parameters of the graph are shown. So basically, the graph represents is best for type 3 cement, which shows the higher compressive strength or temperature rise, and for type 1, 2, 4, and 3, this is the graph between time and temperature rise in mass of concrete, and the temperature shows here, which is in degree centigrade. And here is the graph between compressive strength and the time of concrete. So basically for type 1, this graph shows, and here is the strength presents in MPa or Newton per mm square, and here is the days, which is in So basically for type 1 compressive strength shows this graph, for type 2, 2, 4 and 5 this graph shows, and for type 3 this graph shows. These graphs provide the basic justification in selecting the cement of engineering application. For instance, for massive concrete structure, hydration heat is an important consideration because excessive temperature increase will cause expansion and cracking. So basically type 4 cement should be in the first candidate and type 3 should not be used. So basically जहाँ पे temperature rise आपका ज़्यादा हो रहा है, तो ये ग्राफ आपका ये दिखा रहा है कि जहाँ पे आपका टेम्परेचर राइज ज़्यादा हो रहा है वहाँ पे आप टाइप 3 वाली सीमेंट आप नहीं यूज़ करेंगे, क्योंकि टाइप 3 सीमेंट की जगह पे टाइप 4 यूज़ करेंगे for a foundation exposed to groundwater with high concentration of sulfates, high sulfate resistance is needed. It is clear that कि अगर आप ground water में या high concentration of sulfate और high sulfate resistance की ज़रूरत पड़ेगी अगर आप foundation कर रहे हैं underground water के केस में. So type 5 should be selected. If high early strength is needed, then type 3 will be the best choice. But generally, type 1 is the most popular cement used for civil engineering. So hence, from the language, it is clear that uh, mostly used type of cement, which is type 1 cement, and for groundwater foundation exposure, type 3 cement, sorry, type sulfate resistance type 5 cement is selected, and for where temperature increase, excessive temperature increase where performed, then we are not using the type 3 cement, but type 4 cement should be used. Next topic is porosity of hardened cement paste and the role of water. So knowledge of porosity is also a very useful for the study of concrete or the strength and durability of the concrete. In hardened cement paste, there are several types of porosity: trapped or air entrained, 0.1 to several mm in size; capillary pores, which is the size of 0.01 to a few microns, existing in the space between hydration products; and gel pores within the layered structure of calcium silicate hydrate gel. So basically जब भी सीमेंट का आप पेस्ट बनाते हैं तो उसमें कहीं ना कहीं पोरोसिटी या एयर इंट्रेन थोड़े थोड़े रह जाते हैं. अगर एयर इंट्रेनमेंट की बात करेंगे विच इन द साइज ऑफ 0.1 टू सेवरल एम एम 0.1 mm टू सेवरल एम एम तक रह सकते हैं. कैपिलरी पोर्स होते हैं विच इन द साइज ऑफ 0.01 से लेके certain amount of microns तक. So the capillary pores have a large effect on the strength and the permeability of hardened paste itself. So the presence of air bubbles can also affect strength. From experiment, the porosity within the gel for all normality hydrated cement is the same with a value of 0.26. So this value is experimentally proved. The total volume of hydration product cement gel is given by Vg is equal to 0.68 alpha centimeter cube per gram, where alpha represents the heat degree of hydration. The capillary porosity can be calculated by Pc is equal to water cement minus 0.36 alpha or centimeter cube per gram of original cement, where W is the original weight of water and C is the weight of the cement, and W by C is the water cement ratio. It can be seen that with increase of water cement, the capillary pores increases. So here it is clear that if we are increasing the water cement ratio, the capillary pores also be increased. The the gel to the space ratio is defined as volume of gel divided by volume of gel plus volume of capillary pores, which means 0.68 alpha upon 0.32 alpha plus W by C. The minimum water cement ratio for complete hydration is usually assumed to be in the range of 0.36 to 0.42. It should be indicated that complete hydration is not essential to attain a high ultimate strength. For paste of low water cement ratio, residual unhydrated cement will remain. To satisfy workability requirements, the water added in the mix is usually more than that needed for the chemical reaction. Part of the water is used up to chemical reaction. The remaining is either held by the CSH gel or stored in a capillary pore. Most capillary water is free water, and on drying they will be removed, but the loss of free water has little effect on concrete. So basically it is clear that water cement ratio workability बढ़ाने के लिए हम बढ़ा देते हैं कभी कदार साइट पे, बट ये एक्सेस वाटर या तो कैपिलरी में इकट्ठा हो जाता है और इसको इजीली रिमूव किया जा सकता है बाय द प्रोसेस ऑफ ड्राइंग. But this capillary waters is also affects the concrete. Loss of absorbed water on the surface and those in gel will, however, lead to shrinkage. So basically, this excessive water cause leads to the shrinkage phenomena. Movement of adsorbed water and gel under load is called a creeping in concrete. So basically, this water, जो भी ये water quantity excessive आ रही है capillary में, वो धीरे धीरे move करेगी और ये बाद में shrinkage को भी थोड़ा थोड़ा इंक्रीज करती है, एज वेल एज क्रीप फिनोमेना को भी जनरेट करती है. नाउ द नेक्स्ट टॉपिक इज बेसिक टेस्ट ऑन पोर्टलैंड सीमेंट. तो बेसिकली यहाँ पे हम जितने भी सीमेंट के टेस्ट हैं कई सारे, वो सारे हम इस टॉपिक के अंदर कवर करेंगे. So basically the first test is fineness test. This test determines the average size of cement grains. The typical value of fineness is 350 kilometer square per kg. Fineness control the rate and completeness of hydration. The finer a cement, the more rapidly it reacts, the higher the rate of heat evolution and the higher the early strength. It means कि अगर जितना भी सीमेंट का जो फाइननेस जितनी ज़्यादा रहेगी उतनी जल्दी वो रिएक्ट करेगी rapidly. The higher the rate of heat evolution and the higher the early strength, उतनी जल्दी वो strength भी gain करेगी. For type 1, 3 and 5, which is 350, 450 and 350 fineness. And if we are talking about the strength, which is 6.9, 13.8 and 6.2 for these 1, 3 and 5 types of cement. Next test is about normal consistency test. This test is to determine the water required to achieve the desired plasticity state called normal consistency of cement paste. It is obtained by the Vickert apparatus by measuring the penetration of a loaded needle. So basically consistency test आपका normal consistency या desired plasticity rate state निकालने के लिए किया जाता है, which is done by the Vickert apparatus by measuring the penetration of a loaded needle. Third one is time of setting. This test is to determine the time required for cement paste to harden. Initial set cannot be too early due to the requirement of mixing. So basically initial setting time और final setting time इस cement का निकाला जाता है. 30 minutes and 600 minutes होता है. Final set cannot be too late owing the requirements of strength developed time of setting is measured by the Vickert apparatus. Initial setting time is defined as the time at which the needle penetrates 25 mm into cement paste. Final setting time is the time at which the needle doesn't sink visibly into the cement paste. So basically initial setting time के लिए जो loaded needle Vickert apparatus में use करते हैं वो 25 mm तक penetrate करने चाहिए cement mold को, और फाइनल सेटिंग टाइम में ये है कि वो निडल doesn't sink visibly into the cement paste. Next test is about the soundness. The unsoundness in a cement paste refer to the excessive volume change after setting. Unsoundness in cement is caused by the slow hydration of magnesium oxide or free lime. Their reactions are MgO plus H2, which gives the magnesium hydroxide, and for same for the calcium, which gives the result calcium hydroxide. Another factor that can cause unsoundness is the delayed formation of Etrignite after cement and concrete have hardened. The pressure from crystal growth will lead to cracking and damage. The soundness of the cement must be tested by accelerated method. An example in Lee chart test. This test is to measure the potential for volumetric change of cement paste. Another method is called autoclave expansion test, which use an autoclave to increase the temperature to accelerate the process. So basically, soundness is also a very important parameter for the cement, just because it refers to the excessive volume change after setting of the cement. Now we are talking about the strength. The strength of cement is measured on mortar specimen made of cement and standard sand or silica. Compression test is carried out on the 2 inches cube with cement sand cement ratio of 2.75 is to 1 and water cement ratio of 0.485 for Portland cements. So basically जो ratio रहेगा हमारा sand का और cement का, which is 2.75 to the 1, and water cement ratio is the value of 0.485. The specimen are tested wet using a loading rate at which the specimen will fail is 20 to 80 seconds. The direct tensile test is carried out as specimen shaped like a dumbbell. The load is applied through specially designed grips. Flexural strength is measured on the 40 by 40 by 160 prism beam test under a center point load bending. तो कंक्रीट की तरह ही इसका भी आप फ्लेक्सुरल टेस्ट कर सकते हैं सिंगल पॉइंट लोड के थ्रू. Next is heat of hydration test. Cement hydration is the heat releasing process. The heat of hydration is usually defined as the amount of heat evolved during the setting and hardening at a given temperature measured in joule per gram. The experiment is called heat of solution method. Basically, the heat of solution of dry cement is compared to the heat of solution of separate portion of the cement that have been partially hydrated for 7 and 28 days. So basically heat of hydration जो होगा ड्राई सीमेंट का कंपेयर करेंगे आप 7 और 28 डेज के हाइड्रेशन पार्शियली हाइड्रेटेड सीमेंट से. Heat of hydration is the difference between the heats of solution of dry and partially hydrated cement for the appropriate hydration period. This test is usually done on type 2 and type 4 cement only because they are used when the heat of hydration is an important concern. Type 2 and type 4 cement में heat of hydration test basically किया जाता है just because they are used when heat of hydration is an important concern. So basically heat of hydration is the difference between the heat of solution of dry and partially hydrated cement for the appropriate hydration period. Excessive heating may lead to cracking in massive concrete construction. इसके अलावा कुछ एक्सपेरिमेंट हैं इंक्लूडिंग सल्फेट एक्सपेंशन एंड एयर कंटेंट ऑफ मोर्टार. स्पेसिफिक ग्रेविटी टेस्ट भी इसका सीमेंट का इंपॉर्टेंट है. बेसिकली स्पेसिफिक ग्रेविटी जो सीमेंट की आती है वो 3.15 आती है. Now the next topic is aggregate, which will be covered in the next lecture. So in this lecture we studied about the basic tests of the cement and the porosity of hardened cement paste and the role of water. Also, the compressive strength and the basic typical chemical composition of the cement for all the types. Also, we covered the types of cement. In next lecture, we are proceeding for the aggregates topic. So basically, सीमेंट आपका यहाँ पे पूरा टॉपिक ये कवर हो जाता है. सीमेंट की केमिकल फिजिकल प्रॉपर्टीज टेस्ट एंड इंग्रेडिएंट्स. थैंक यू.